electron and a proton are allowed to fall through the separation between the plates of a parallel plate capacitor of a charge 5 volt and separation distance h equals 1 mm as shown in the figure. Let us look at the diagram. So here you have the diagram. The electron moves from negative plate to the positive plate because of the electrical force. Few datas are given. Let us check out what are all the datas given. Mass of the proton 1.6 into 10 power minus 27 kg. Mass of the electron 9.1 into 10 power minus 31 kg. And the acceleration due to gravity we are asked to take 10 meter per second square. Right? We are asked to find what is the time of flight for the electron. Solution. So what are the various data given here? The potential difference between the two plates is 5 volt and separation between the plate is 1 mm, that is equal to 1 into 10 power minus 3 meter. The mass of the electron is 9.1 into 10 power minus 31 kg. And the charge of the electron is 1.6 into 10 power minus 19 coulomb. So let us find the time of flight for the electron. So let us state the basic equations of motion. S is equal to ut plus half at square. In this, u is the initial velocity. Here the electron's initial velocity is 0 and the distance travelled s equals the separation between the plate equals h. So the formula has been changed into h is equal to half a t square. Here the a stands for acceleration of the electron. So let us change this equation to time of flight t equal to root of 2h by acceleration of the electron. So let us find what is the acceleration of the electron. That will be equal to force by mass of the electron, and the force is replaced by the charge time electric field. So small e times capital E. Now we have to find what is the value of this electric field from the potential gradient between the two plates of a capacitor del V by del D. So which is equal to 5 divided by 1 into 10 power minus 3. So we get the electric field as 5 into 10 power plus 3 volt per meter. So let us go back to finding the time of flight of electron. So t equal to root of 2hme by ee. We replacing the acceleration of electron by capital E small e divided by mass of the electron. So the time of flight for the electron equals root of 2 times the h. h is 1 into 10 power minus 3 into the mass of the electron is 9.1 into 10 power minus 31 kg divided by the electric field strength E 5 into 10 power 3 and the charge of the electron is 1.6 into 10 power minus 19 coulomb. So after calculation we find the time of flight as 1.5 nearly equals 1.5 nanosecond. In this calculation we completely ignored the force of gravitation, the force of gravity. Let us now find the next part of the same question. Calculate the time of flight for proton. Look at the diagram. Now this proton is moving from positive plate to negative plate. In this section, the electric field, the potential equals to the potential gradient. It hasn't been changed, right? The potential difference still is 5 volt and the separation between the two plates is still 1 mm. So the electric field between the plate, anywhere, any point between the plate E equals 5 into 10 power 3 volt per meter. Right. What are the other data we require here? The mass of the proton is 1.6 into 10 power minus 27 kg and the charge of the proton equals 1.6 into 10 power minus 19 coulomb. So let us go and find the time of flight for proton. So these are all the same steps we have seen it for electron. So here h is equal to half acceleration of the proton into the time square. So time of flight t equals root of 2h by acceleration of the proton. The acceleration of the proton is ap equals force by electric field by mass of the proton. The mass of the proton is much larger than, much greater than the mass of the electron. So the acceleration experienced by the proton is less than the acceleration experienced by the electron. The force is replaced by charge time the electric field small e into capital E. Let us substitute this acceleration of the proton in our time of flight equation. We get t equal to root of 2h mass of the proton by electric field strength into the charge of the electron. So let us substitute the values of h as 1 into 10 power minus 3 meter. Mass of the proton is 1.6 into 10 power minus 27 kg. We substitute the electric field intensity as 5 into 10 power 3 volt per meter. Charge of the proton is 1.6 into 10 power minus 19 coulomb. So after calculation, we found that the time of flight for proton nearly equals 63 nanosecond. So compared to electron, this will be a larger value. So it goes very slowly, right? So here too we ignore the gravity. Let us go for the third part of the problem. Suppose if a neutron is allowed to fall, what is the time of flight? Here the charge on each plate is ineffective. The neutron is having a neutral charge, so it is not affected by the electric field. So here you no need to find the electric field strength and all. So you go straight to find the time of flight by using the same equation. We get t, h is equal to half gt square. Look at here, the acceleration is replaced by acceleration due to gravity. So half gt square, the g value is given in our problem as 10 meter per second square. So the time of flight for this neutron equals root of 2h by g. Let us substitute the value of h as 1 mm and the g value as 10. We get the time of flight for neutron is 1.414 into 10 power minus 2 second. That's equals 14.14 millisecond. Look at this time of flight. This is around 1 million times larger. That means 1 million times slower. The value is larger, whereas it starts go very slow, 1 million times slower. It will reach the other side or the opposite plate. So now the last question of the problem, among the three, which one of the particle will reach the bottom first? So time of flight for electron is around 1.5 nanosecond, time of flight for proton is 63 nanosecond, and time of flight for neutron is 14.14 millisecond. Out of all these three, the electron is having the least value, that will reach the first to the bottom plate.